UP is a complete university where we have all the disciplines offered in various colleges. And the way we design our engineering courses, the students to interact with students of other courses, that's a learning that only, I guess, in UP they can get, because the so-called general or interdisciplinary opportunity of learning in UP is broadest just because we have the most number of courses. Only in UP could you do this, I think, consistently.
The cheapest, arguably the best education that you can get. That's why you should go to UP.
I see the UP College of Engineering to be the best institution to take your engineering because of the professors who have taken their PhDs in higher education. The students themselves will be a cream of the crop, as they say. Anybody who's interested in going to UP, please do, although it's very difficult to enter.
There is really a wealth of expertise. Over the years, we have built up also facilities are already up to date and can be used for very good research projects.
There's a lot of things in Diliman that you can learn outside the classroom, like joining organizations, fraternities, or being involved in other extracurricular student activities, which will probably give a more rounded education.
UP College of Engineering has a history of producing the best engineers in the land.
Engineering is one of the best colleges in the universities. You can't have any other choice.
UP teaches you resilience and resourcefulness, and that's not something that's easily taught. It's something that you learn because of the way you get your UP education. You really have to rely on your wits. Nobody will tell you what to do. You have to figure it out. And those qualities of resilience and resourcefulness are critical when you go out into the real world. Because when you're working, nobody will tell you what to do. But the best people are the ones who can figure things out for themselves.
Engineering school, go for UP. It still has the track record of being one of the best.
The one thing that you learn at the UP College of Engineering is to be resourceful. And because you are taught the fundamentals, the theories, it is easy for you to extend it to different applications.
It's because it's the #1 school. In every survey that comes out, global ranking, Asian ranking, Philippine ranking, it's always #1.
If you're looking for meaningful challenges, solutions to challenges that face our society now and into the future, you will meet people who are passionate about their field, who are willing to mentor you and to take whatever it is that you have and mold it into something better. Start your career here in the UP College of Engineering.
Okay. Good afternoon. Good afternoon, everyone. So welcome to the sixth graduate research colloquium of the Institute of Civil Engineering, University of the Philippines, Diliman. My name is 𝗘𝗃𝗂𝗏. I'm the graduate program coordinator, and I'll be moderating this colloquium. So this colloquium is composed of two parts. The poster presentations that was just recently concluded on site. That was on site here in 𝗖𝗃. Then the second part is this online meeting now, wherein we will see presentations from students who have completed their graduate thesis in the field of transportation engineering and structural engineering. So just a recap of what happened earlier now. So these are the poster presentations, and yeah, here are some photos of the event. So we had the lively discussion, interaction among the participants and the presenters. Okay. So for this session, this part, so we have 5 presenters, as I mentioned, and each one will give about 10 to 15 minutes about their study. So for the program, we have a welcome remarks by the 𝗖𝗃 Deputy Director for Academic Programs, Dr. 𝗘𝗃𝗂𝗏𝗂𝗏. Then we'll have a group photo. Then we'll proceed with the individual presentations, and then closing and feedback. Okay, some webinar policy. Okay. Keep your microphones muted at all times. Use the Q&A box for your questions. State your name and affiliation before your questions. The moderator will read your question after the presenter has finished his or her presentation. The presenter may address your question directly in the Q&A box or live. Okay, so we will give about 5 minutes for the live answering of the questions in the Q&A box. So questions that will not be answered due to the limited time will be forwarded to the presenter to be answered offline. Of course, even if the presentation has already finished, you can still input your questions in the Q&A box, and the presenter will respond to that question in the Q&A box too. Then certificates of attendance now will be issued when you accomplish the feedback form through the QR code that will be flashed at the end of the colloquium. Okay. So let's to formally start our graduate research colloquium part 2. Let's welcome Dr. 𝗘𝗃𝗂𝗏𝗂𝗏, the Institute Deputy Director for Academic Programs.
Hi, good afternoon, everyone. Good afternoon, Dr. Errol. Thank you. My task here is, of course, to welcome you, to welcome all participants on behalf of the Institute and, of course, our director, Dr. 𝗘𝗃𝗂𝗏. We warmly welcome you to this online 𝗖𝗃 Graduate Research Colloquium for this year 2026. As already mentioned by Dr. Errol, we actually had 2 parts. The first part being the poster presentation, where we listened to 4 presentations. So siguro ikwento ko lang briefly kung ano yung mga present kanina. We had a presentation by Ms. Erica Gomez, who is now a candidate MS. Who is in our MS program, MSCE program, so it's a structural, and that was on the effect of debris, windstorm surge debris on low-rise residential structures. So she wants to study kung ano magiging epekto ng combination ng wave, ng wind, at saka and debris, no, to existing structures, no, like houses or residential structures. And I think I found that very interesting. And then sa number 2, it was presented by Engineer Oraya, who is now naman a PhD candidate, no, in CE, water resources natin. So, present naman niya ay yung non-stationary tri-variate flood frequency analysis, probabilistic hydrograph-based inundation mapping. So, basically, she wants to improve, no, models, particularly in modeling yung mga flood inundation in built-up areas, para maka-contribute later on in recommending better river policies and perhaps flood structure design standards. And then the third presentation earlier was poster presentation earlier was by Engineer 𝗙𝗵𝗱𝗀, again a PhD candidate sa water resources and / coastal engineering track natin. Ang subject matter naman niya ay yung riverine and coastal hydrodynamic interaction during a storm surge. No? I think he wants to consider yung situation na sabay-sabay nangyayari. Meron kang coastal storm surge, meron kang wind, tapos merong river flow. No? So I think maganda, that's a particularly interesting study as well kasi hindi natin alam pa kung ano nangyayari nun. And those might be, causes why we are having more damaging hazards, causing more damage, hazards that cause more damages in our coastal areas. And then the last one was presented by Ms. Aliana Terite, MSCE naman on structural. And this was on seismic retrofitting. So she wants to develop a genetic algorithm tool, no, for analyzing yung seismic retrofitting, no, and that is an improvement. She contrasted it with yung mga current models natin na trial and error design. So it's going to be more efficient, so to speak, in analyzing what we can do about when we design seismic retrofitting. So we also want to thank those 4 presenters, no, yung poster presentation kanina, and we learned a lot from your presentation. So thank you very much. So as mentioned by Doc Errol, from here on, we are about to listen to 5 additional complete oral presentations. Well, we all know that research knowledge must be disseminated, no, so that we ensure na yung output knowledge will reach yung desired application nila, particularly perhaps in designing and implementing better infrastructure and systems, of course, for the betterment of our community, the nation, and perhaps even contribute to global knowledge. No? So that is why we are holding this colloquium, first of all, to provide a platform for our graduate students to inform us, no, about their research and their output. And for other students in our colloquium this afternoon, we hope that you will be inspired, no, in pursuing your own research in a manner that is consistent with our values of, knowledge, excellence, and of course, very important, service. No? And perhaps yung mga presentations will also inspire you to choose yung topics to pursue in your research. And perhaps for the general audience, simply to gain knowledge, no, or to gain or learn new knowledge, which is of course what this colloquium is all about. So I hope that you would listen to the presentations with expectation of learning new things. No? And please feel free to give comments or ask questions. Doc Errol already gave you the mechanics on how to do that later on. And with that, I just want to wish everyone a pleasant and fruitful afternoon. Maraming salamat.
Thank you, Doc Shan. Okay. So before we go to the first presentation, now let's have a group photo first. Okay. So presenters and I'm sure if the audience can open their cameras. So let's have a presentation. Jill, kindly take the photo, please. And let us know now if you'll be taking the photo.
Wait po, Doc. Smile po. 1, 2, 3. Another one po. 1, 2, 3. Ayan, okay na po, Doc.
Okay, thank you, Jill. So now we go to the presentations. Okay, so allow me to introduce the first presenter. So our first presenter is Engineer Christine Joy B. 𝗷𝗃𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 She has 13 years of experience in the field of road safety engineering. She is affiliated with the Department of Public Works and Highways under the Road Safety Program Division and is presently reassigned to the Batangas 1st District Engineering Office. So let's listen to the presentation of Engineer 𝗷𝗃𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀.
Thank you, Doc Errol. So let me share my screen. So visible po yung presentation.
Yes, you may start.
Okay. So good afternoon, everyone. My presentation is the validation of IRAP Star Rating Protocol, a case study of a Philippine highway corridor. And my advisor is Dr. Jose Regine F. Regidor. So this is, sorry. So this is the outline of my presentation. I'll begin with the introduction first. So road crashes continue to claim the lives of approximately 1.3 million people each year and injure about 20 to 50 million people. So these incidents lead to serious consequences, including the loss of productive capacity, income, and human resources. In the Philippines, according to the Philippine Statistics Authority, there is a reported fatalities of 6,869 from 2006, and it rose to 11,292 in 2016. So that translates to 64% increase and an annual increase of 4.8 for over a decade. So this trend underscores the alarming road crash trauma in the country. There are generally two approaches in road safety management. The first one is the reactive approach, and then the second one is the proactive approach. Under the reactive approach, it relies on historical data using the crash database and analysis system. So in the Philippines, we had the traffic accident recording and analysis system, which was developed by the DPWH in coordination or in partnership with the ADB or the Asian Development Bank. So TARAS is designed to record and analyze road crashes, providing valuable data for traffic safety. However, the system was terminated in 2013. And then another software or innovation was introduced. So the data for road incident visualization, evaluation, and recording system, or the drivers. So this one is developed by the DOTR together with World Bank. However, this is not yet operational due to lack of funding. Now, the problem is that there is currently no operational crash data system being used in country. So another approach is the proactive. So it relies on or focuses on road infrastructure attributes to predict and prevent crashes. An example of this is the International Road Assessment Program, or the IRAP. What is IRAP? IRAP is a global nonprofit organization which aims to reduce road trauma by conducting road safety assessments and improving road infrastructure. Basically po, yung IRAP, it uses design features to predict the likelihood and the severity of crashes or injuries. And it assigns star ratings from 1 to 5, with 5 being the safest roads. To understand the concept of star ratings, we can compare it with hotel star ratings. So, for example, a 5-star hotel rating indicates a higher level of quality of service, such as a more luxurious accommodations, larger rooms, and a higher standard of hospitality. So therefore, in terms of the IRAP star ratings, the higher the star ratings means a safer road and therefore lower crash risks. Now, under the Philippine Road Safety Action Plan for 2023 to 2028, the IRAP star ratings is already in place with the goal of achieving and maintaining 3-star ratings on over 50% of the total road network. Now, since we are adopting an international standard, it is valid to ask how well does the star rating correlates to actual safety outcomes. Now, for the objective of the study, it is to demonstrate the validity of IRAP star rating concept for application in the Philippine national roads by comparing star ratings with actual crash data. So the star ratings on this study will focus only on the vehicle occupant star ratings. And then for the crash data, we will be using the PNP blotter system. But this system, although it contains crash data, this one is in spreadsheet form. So it contains information regarding the time, the date, the location, the longitude, and the information about the crash is located in the narrative format. So, kumbaga, yung sa e-blotter, nakakwento doon lahat ng nangyari doon sa crash, and doon mo makikita kung ano yung mga, let's say, kung ano yung mga crash type, ano yung mga vehicles involved. So, the study area, it focuses on the Cagayan de Oro Davao General Santos Highway with a total length of 428.20 kilometers. And this shows the map of the road section. As you can see, majority of the road section has 4-lane undivided and 2-lane undivided roads. So therefore, yung study focused only on these 2 types of carriageway. For the results and discussion, I'd like to show information about dun sa mga na-identify na mga road crashes on that road section. So as you can see in this slide, yung mga dominant crash types natin are the same direction, opposing direction, and the intersection crashes. Now, I'd like to show the relationship between the vehicle occupant star ratings and the vehicle occupant crash rates on 4-lane undivided roads. So for the study, I utilized 3 aggregate analysis periods: the 5-year from 2016 to 2020, the pre-survey 2016 to 2018, the 3-year 2017 to 2019, or the post-survey. So the expected relationship is that kapag mas mataas yung star ratings, dapat mas mababa yung crash rates. But in this graph, or in this figures, you can see na pataas siya, or it contradicts the expected relationship. So for all periods, makikita natin na significantly na tumataas yung crash rates kapag mas mataas yung star ratings. And then I used the negative binomial generalized linear model to calculate or to evaluate the statistical significance dun sa significant changes in crash rates, particularly comparing the 2-star versus the 1-star and the 3-star versus the one-star road segments. And makikita natin yung mga naka-highlight ng yellow, these are combinations with statistically significant but counterintuitive relationships. But then I also noted a case wherein statistically significant but follows the expected relationship but on speed of 60 kph. So siya lang yung bukod tangi for a 4-lane road. Now, because of that counterintuitive relationship, I consulted with Greg Smith, currently the IRAP Chief Executive Officer, and according to him, the IRAP model assumes that overtaking on opposing side is reduced on multi-lane road. So kung makikita nyo dun sa, wait lang, dun muna sa isa. So if you'll observe that yung IRAP model assumption is that the overtaking only happens on the same lane, same direction, but not on, or nalilesen siya kapag multi-lane roads. Dito naman sa local driving behavior natin sa Philippines, and also kung maaalala nyo yung pinakita kong slides regarding yung mga dominant crash types natin na andun yung yung overtaking and opposing direction. So therefore, iba yung local driving behavior natin with the IRAP model assumption. And then also to verify this claim, I utilized the IRAP demonstration tool to check to the same road section, the same configuration, 4 lanes, but the segments with median versus the segments with a physical median. And as you can see, doon sa naging result niya, parehas pa rin siyang nag-fall doon sa 3-star ratings kahit na yung isa is with median or physical median. So this suggests that there is a potential underestimation of overtaking related risks in the study corridor for 4-lane undivided roads. And it also suggests the need for contextual calibration of the IRAP model. Now for the 2-lane undivided roads, so on all of the analysis periods, visually we can say that ito yung mas nag-follow with the expected relationship wherein pag mataas yung star rating, mas mababa yung crash rates. And then upon the testing the statistical significance, lesser yung, meron pa rin tayong na-identify na counterintuitive, however, mas marami yung na-identify natin na mga following the expected relationship which is the decreasing trend. And it is also important to note that nakita natin, kung mapapansin nyo kung iisa-isahin natin siya, yung speed nito, makikita natin again yung stronger alignment of star ratings and crash outcomes on 2-lane undivided roads, particularly kung iisa-isahin natin yung mga road segments, it falls with lower speed limits, so at 60 kph. So for the overall applicability of IRAP star ratings, although we noted contradictory results in the data analysis, the study identifies opportunities for improvement and therefore does not diminish the value of the IRAP star rating methodology. We still recognize that the IRAP approach is still favorable, especially for countries like us na wala tayong crash database system. So IRAP offers cost-effective measures. So ito yung maganda kay IRAP. It has cost-effective countermeasures and supports strategic road safety investment planning. And then for the recommendation of this study, star ratings on 4 lanes should be interpreted with caution and supplemented with additional safety analysis. And then explore the development of a specific Philippine-specific road safety assessment And then also to integrated safety assessment approach. So star rating assessment, it should not complement and not replace crash-based analysis. And the combination po nung dalawa, ng proactive and reactive, can help us to have comprehensive understanding of road safety risks. And also, in addition, to conduct additional local studies, because it can vary, depende po siguro din sa lugar. If there are further studies, then mas maganda para mas makita po natin talaga yung relationship with IRAP star ratings and crash rates. And these are the references that were used in the study. So that ends for my presentation.
Okay, thank you. Ms. 𝗗𝗃𝗀𝗀𝗀𝗀𝗀. So we now go to the Q&A for this presentation. Allow me to read one question. Given the issue of underreporting of road crashes in the Philippines, to what extent can the validation results still be considered reliable?
So yes po, actually dito po sa study, malaki po talaga yung chance na may underreporting because if I may present pa, pero siguro wala ng time. Pero nakita po natin dun sa data na dun sa 2018 na data niya is merong significant dip or mababa yung crash rates and yung crash data collection, and we don't have I haven't identified kung ano yung reason behind that, but still I think that to understand yung validity of star ratings, we need to start somewhere, and we need to use the available information na meron tayo. Kasi kung hindi, di parang wala, bias lang din yung magiging observations natin. And also, we need to take into consideration that the reliability of the results is indicative rather than absolute. So we need to siguro mas marami pong studies, and yan po.
Okay. So thank you, Ms. Christine Joy 𝗗𝗃𝗀𝗀𝗀𝗀 for your presentation. To the attendees, if you have other questions, you want Engineer Christine to answer in relation to her completed graduate thesis, you may use the Q&A box, and Engineer Christine will answer them there. Okay. Again, thank you, Ms. Christine. I would like to present you the certificate. Allow me to may I request you to stop sharing, then I'll okay. So okay, so this certificate of appreciation is presented to Engineer Christine Joy 𝗵𝗃𝗀𝗀𝗀𝗀 for sharing her research expertise as presenter in the 2026 Graduate Research Colloquium, given this 24th of April 2026 at the Institute of Civil Engineering, University of the Philippines, Diliman, signed by the Director of the Institute, Dr. Jose Regine F. Regidor. Thank you, Ms. 𝗗𝗃𝗀𝗀𝗀𝗀𝗀.
Thank you po. Thank you, everyone.
Okay. The next presenter is Engineer Bill John B. De Vera, who is a graduate of Bachelor of Science in Civil Engineering and Master of Science in Civil Engineering, major in Structural Engineering. His research interests include construction materials, non-destructive testing for material evaluation, and machine learning applications in materials research. He currently has one publication in Results in Engineering journal. He currently works as a faculty member at the Technological Institute of the Philippines, Quezon City. Let's listen to Engineer Bill John De Vera.
Good day, I am 𝗍𝗵𝗂𝗧𝗏 and I would like to present my research entitled Estimation of Withdrawal Strength of Different Nail Diameters in Coconut 𝗃𝗃 lumber subjected to accelerated aging cycles using ultrasonic tests and multiple linear regression analysis. My research advisor is Dr. Oscar Victor M. Antonio Jr. Here is my presentation outline. To give everyone a context of my study, people often live in non-engineered structures outside urban areas. These structures have little to no engineering intervention and are more vulnerable to natural hazards such as typhoons. Last 2013, Typhoon Haiyan caused damage to several structures in the Philippines, and roof failure is the most common failure mode. For example, on hip roofs, pull-out or withdrawal failure is a typical failure mode. These figures show Typhoon Haiyan damage to wooden roofs or trusses. Previous studies investigated the influence of different factors such as nail diameter, cracks, and rust on nail withdrawal strength in wood. However, these destructive tests damage the specimens and cannot be used once the testing is performed. To date, there is also no study for estimation of nail withdrawal strength of different nail diameters in wood using ultrasonic tests, a non-destructive test. To address this gap, this study primarily aims to develop an empirical model, that is, a regression model for estimating nail withdrawal strength in coconut lumber with different nail diameters and ultrasonic test parameters while accounting the effects of accelerated aging. If successful, the study will provide an empirical model for nail withdrawal strength in coconut lumber and improve the design of non-engineered structures in the Philippines. This study will also serve as a pioneer study producing regression models with ultrasonic test parameters as independent variables. To achieve this, the study started from preparing the necessary wood and nail samples for experiment implementation. The prepared samples were subjected to different number of accelerated aging cycles. Ultrasonic and withdrawal tests were then implemented. The effects of different number of accelerated aging cycles to wood and nail samples were assessed. Finally, statistical and regression analyses were performed to determine the relationship between nail diameter, number of accelerated aging cycles, ultrasonic test parameters, wood density, and nail withdrawal strength. A typical non-engineered house roof frames in areas affected by Typhoon Haiyan are made of coconut 𝗃𝗃 lumber. Coconut lumbers free of defects with approximately constant grain orientation were selected, and 30 mm by 40 mm by 150 mm wood samples were cut. To ensure consistency, the wood samples were moisture conditioned inside a conditioning chamber at 20 ± 3 degrees centigrade temperature and 65 ± 3% relative humidity for 4 weeks. These figures show the moisture conditioning of the samples. 3 types of smooth, electrogalvanized common nails, that is 2-inch or 50 mm, 2.5-inch or 65 mm, and 3-inch or 75 mm long nails were used in this study. The average nail diameters were 2.76 mm, 3.44 mm, and 4.24 mm for 2-inch, 2.5-inch, and 3-inch long nails respectively. Each nail was hammered at a right angle into the center of 30 mm by 150 mm face of a wood sample. The nail was marked and embedded 40 mm into the wood sample. Wood samples that exhibited splitting were discarded. Since it was not feasible to perform years of outdoor aging, an accelerated aging procedure was implemented to simulate environmental degradation effects on the samples. The procedure involves alternating steps of soaking, steaming, and oven drying. The setup for this procedure consisted of soaking the samples in thermostat water baths, steaming the samples in a 5-layer steaming cabinet with temperature control, and drying the samples in an oven, as shown in these figures. To examine damage progression, 5 samples for each of the 3 nail diameters considered were exposed to 0, control group, 1, 2, 4, and 6 accelerated aging cycles, resulting in a total of 75 samples. Hereafter, and for ease in reference, samples hammered with 2-inch, 2.5-inch, or 3-inch long nails are represented as nail groups of N2 and 2.5 or N3 respectively. Samples exposed to 0, 1, 2, 4, or 6 accelerated aging cycles are represented as cycle groups of A0, control group, A1, A2, A4, or A6 respectively. Samples hammered with a particular nail size and exposed to a particular number of accelerated aging cycles are represented by a combination of corresponding notations, that is, nail cycle group. For instance, N2.5A2 represents samples hammered with 2.5-inch long nails and exposed to 2 accelerated aging cycles. Ultrasonic testing was conducted inside the conditioning chamber before the withdrawal testing. The following were the materials and equipment used for ultrasonic testing. The figure shows the side and top views of the configuration used on the testing. 2 types of equipment setup were implemented. The first setup consisted of Pundit Lab ultrasonic instrument to accurately measure the ultrasonic pulse velocity or UPV parameter. The following were the settings used. 3 trials were conducted to ensure measurement reliability. The figure shows the equipment set up for UPV measurement. The second setup was composed of an arbitrary waveform generator, Rigol DG1022, an amplifier, AIM TTI-WA301, and an oscilloscope, Rigol DS1054Z, to obtain attenuation coefficient, another ultrasonic parameter. The following were the settings used. The figure shows the equipment set up for attenuation coefficient. Withdrawal testing was then conducted. Nails were withdrawn using an Instron 3366 universal testing machine. A small cross-sectional wood sample, 30 mm by 40 mm by 25 mm near the nail location was cut from the original sample. The density at the particular moisture content, that is, the actual wood density, the moisture content, and the oven dry specific gravity of the small sample were determined. The figure shows the withdrawal test setup. To develop the regression model, nail diameter, number of accelerated aging cycles were considered as categorical variables. To account for different levels of categorical variables, dummy variables were used as shown. For example, if the sample is from N2.5 group, the N2.5 variable will have a value of 1 and the NT variable will have a value of 0. Two-way interactions between nail diameter, number of accelerated aging cycles are also considered in the study to represent nail cycle groups. The final input variables considered in the study are AC, UPV, 1 over rho cube, N2.5, N3, A1, A2, A4, A6, N2.5A1, N2.5A2, N2.5A4, N2.5A6, N3A1, N3A2, N3A4, and N3A6, where AC, UPV, and rho are attenuation coefficient, ultrasonic pulse velocity, and wood density respectively. On the other hand, the final output variable in the study is LNWS, or natural logarithm of withdrawal strength. All possible regressions procedure was implemented to select the best model. After implementing regression analysis, the 6 predictor model is considered as the final and overall best model in the study. In equation form, the best model is as shown. The black line in the figure indicates an ideal case where the predicted values equals the actual values. The figure shows that the points are dispersed away from the ideal black line, indicating poor point prediction performance of the best model. This can be attributed to reducible and irreducible errors. Errors can be reduced by using the best machine learning technique to predict withdrawal strength. However, more flexible and complex machine learning techniques such as bagging, boosting, support vector machines with nonlinear kernels, and neural networks typically require larger and impractical sample sizes. On the other hand, random errors will still exist and are irreducible. These can be attributed to factors that are either unmeasured or inherently unmeasurable, such as nail surface and moisture content variations that can influence withdrawal strength. With the inclusion of prediction intervals, the best model achieved a coverage probability of 95.6% and prediction interval length of 104.61%. This indicates that the best model has good coverage probability but fairly wide prediction intervals. This captures variability such as due to environmental conditions and coconut number water uptake in future observations of nail withdrawal strength. From the previous discussions, it can be deduced that the best model exhibits poor point prediction but acceptable interval prediction performance. Prediction intervals depend on the residual mean square, or RMS, and the t multiplier. Meanwhile, RMS depends on the adequacy of the best model to be an unbiased estimator of the population error variance. During the development of the regression model, the best model satisfies the model assumptions and therefore is adequate. Moreover, the t multiplier depends on the assumption that the prediction errors are normally distributed. The plot shows that the prediction errors fit along the diagonal line, implying that the errors are approximately normally distributed. This all leads to the best model having an acceptable interval prediction performance. Now the figure compares the lower prediction bound coverage probability of the best model to structural codes such as National Structural Code of the Philippines 2015 or NSCP 2015 and National Design Specification for Wood Construction 2024 or NDS 2024. The figure indicates that the lower limits of the 95% and 99% prediction intervals of the best model only have 1 and no points below the limits respectively. Overall, the best model achieved a lower prediction bound coverage probability of 98.4%. However, NSCP 2015 and NDS 2024 have several points below them and only achieve a coverage probability of 69.33% and 65.33% respectively. In other words, both structural codes overpredict withdrawal strength at several instances. This may lead to potential failure of timber connections under actual loading conditions. This is because these codes mainly consider structural wood than non-structural wood such as coconut lumber. The lower prediction bound of the developed model, that is, the best model in this study, may supplement these structural codes and be used to conservatively estimate withdrawal strength of coconut lumber in non-engineered structures in the Philippines. Nevertheless, it is important to note that the developed model has fairly wide prediction intervals and considers a limited sample size. This means that the developed model may yield inaccurate predictions when used outside the range of wood properties, for example, density, considered in the study. The results of this study can be used to perform structural health monitoring of non-engineered structures, detect early damage, and prevent catastrophic failure. The developed empirical model can also provide a conservative estimate of withdrawal strength without destroying the material itself. The estimated withdrawal strength can supplement existing structural codes which currently do not account on non-structural wood such as coconut lumber. Lastly, I would like to acknowledge the support and funding of Department of Science and Technology, Engineering Research and Development for Technology, College of Engineering, University of the Philippines, Diliman. Its support and funding were essential to implement the entire experimental procedure and complete this research. Thank you for listening. Here are my references.
Thank you, Engineer Bill. So now we will go to the question and answer. We have a question here. Can the empirical model proposed in the study be applied to predict the nail withdrawal resistance of wood from other tree species?
Thank you for that question. So, unfortunately, the model cannot be directly applied to predict the nail withdrawal resistance of wood from other tree species. This is because coconut wood has different physical and mechanical properties from other wood species. With this, coconut wood will have a different response when subjected to accelerated aging cycles compared to other wood species. Nevertheless, I believe that the study can still serve as a useful reference for future studies on building a model to predict the nail withdrawal strengths of their corresponding wood species used in construction.
Okay, thank you, Engineer De Vera. Are there other questions? So for the attendees, now, if you have questions later, you can use the Q&A box, and Engineer De Vera will answer them there. Okay, so allow me to award the certificate to Engineer Bill. The certificate of appreciation is presented to Engineer Bill John B. De Vera for sharing his research expertise as presenter in the 2026 Graduate Research Colloquium, given this 24th of April 2026 at the Institute of Civil Engineering, University of the Philippines, Diliman, signed by the Director of the Institute, Dr. Jose Regine F. Regidor. Again, thank you, Engineer Bill De Vera. So to introduce the next speaker, I'd like to call the next moderator, Dr. Hill Cruz.
Thank you, Doc Kinay. Good afternoon, everyone. So I'll be facilitating the succeeding presenters for today's colloquium. So for our next presenter, she is Engineer Sheila Grace Hebra. She holds a Master of Science in Civil Engineering with specialization in Transportation Engineering. She has 5 years of experience in highway design engineer as a highway design engineer at the Bureau of Design, contributing to the planning and design of major road infrastructure projects. She is currently a faculty member in the Civil Engineering Department at Caraga State University, where she is engaged in teaching and research. So to present her topic entitled Evaluation of Maintenance Intervention for Rigid Pavements on the Philippine National Road Network, again, our next presenter is Ms. Sheila Grace Hebra.
Ms. Hebra, sorry, I think you're not sharing. You're sharing without the audio.
Good afternoon, everyone. I am Sheila Grace Hebra, and I'm going to present you my study titled Evaluation of Maintenance Intervention for Rigid Pavements in the Philippine National Road Network. This outlines my presentation. Highways play a crucial role in enabling the safe and efficient mobility. It directly supports the country's economic activities. Proper budgeting and maintenance are critical to keep reliable and sustainable. To support these decisions, the BWH uses a pavement management system, as conditions, and prioritize maintenance. Despite having a PMS, studies like Dr. Napalang highlight issues in maintenance, including budget misalignment and poor data quality. delayed in consistent timing, some roads were repaired while others were neglected, causing disruptions and economical.
I think Miss Hebra is having a technical problem or connectivity issues. Okay, she's now connected again. Engineer Shella, can you share again your screen?
Okay. I'm so sorry, sir. I'm having a slow internet connection. I'll just repeat again. Um, can you see my screen? So I'll just, I think this would be better than playing the video.
We're not yet seeing your screen. It only says Sheila has started screen sharing. Okay. It's not yet on full screen.
Okay. Is my screen already shown?
Not yet. Anyway, Miss Hebra, Miss Shella,
Sir.
perhaps in the interest of time, maybe we can skip first your presentation while you're still fixing your connectivity issue. May I
Yes, sir.
ask if the next speaker is already on Zoom? Are you here, Mr. Pasilaw?
Hello, good afternoon. Yes, nandito na po ako.
All right. So is it okay, Miss Hebra?
Yes, sir. It's okay po.
All right.
So much.
So will you will be the next presenter after Mr. Nathaniel. So please stand by. So I'll just introduce the next speaker, no? So all right. So again, apologies for the technical issues. We'll proceed with the next speaker, and we'll go back to Miss Hebra after Mr. Pasilaw's presentation. So just to introduce the next speaker, Mr. Nathaniel Pasilaw is a graduating student in the Master of Science in Civil Engineering program specializing in structural engineering. Study focuses on the application of evolutionary algorithms, particularly genetic algorithms, in optimizing structural retrofit solutions within the context of seismic design. So specifically, his research aims to develop a systematic and computational framework for identifying efficient seismic damper configurations with the goal of enhancing the seismic performance, safety, and dynamic response of existing structures. Nathaniel has more than 5 years of professional experience in structural engineering industry and currently works as a structural design engineer at 𝗖𝗍 Corporation. In this role, he is involved in the analysis of design of low to high-rise reinforced concrete and steel buildings, contributing to the development of safe, efficient, and code-compliant structures. Again, our next speaker is Mr. Engineer Nathaniel Pasilaw.
Allow me to share my screen lang po.
Sure.
Is my screen visible na po?
Yes, we can see your screen now.
All right. Good afternoon, everyone. I am 𝗚𝗏𝗂𝘂𝘶, and I'll be presenting my study entitled Optimization of Fluid Viscous Damper Placement Using Genetic Algorithms during the Parametric Design Stage of Seismic Retrofitting for Existing Structures. This research was completed under the supervision of Dr. 𝗓𝗏𝗀𝗂𝘂𝘁, and the goal of this study is to enhance the global seismic performance of a structure using fluid viscous dampers while minimizing the quantity needed. The presentation will follow the sequence shown herein. The seismic safety of existing buildings has become a critical concern, particularly in seismically active countries like the Philippines, where many structures were designed under outdated codes or informal practices. This has increased the importance of seismic retrofitting to reduce structural vulnerability and protect life and infrastructure. Among retrofit technologies, fluid viscous dampers are widely used due to their ability to dissipate seismic energy without significantly increasing structural stiffness or mass. However, their performance is highly sensitive to placement. In parallel, parametric and generative design methods are increasingly used in engineering to explore large design spaces systematically, with genetic algorithms offering a suitable optimization approach for discrete and nonlinear problems. This has led to growing interest in applying optimization techniques at the early stages of seismic retrofit design, where key decisions are made before detailed design and cost commitment. Despite the effectiveness of fluid viscous dampers, their placement in retrofit practice is still commonly based on heuristic judgment or simplified design approaches, which can result in inefficient or suboptimal configurations. In current workflows, damper placement is rarely optimized using systematic and analysis-based methods during the schematic design stage, where early decisions strongly influence overall retrofit performance. Although genetic algorithms are well suited for discrete optimization problems such as damper placement, they remain underutilized in practical retrofit design workflows, particularly for complex irregular structures. The objective of this study is to develop a computational framework to optimize the configuration of FVDs in retrofitting an existing structure. This is achieved through the following specific objectives. Number one is to develop a Python-based code implementing genetic algorithm interfacing with structural analysis software. Number two is to assess the effect of the different damper configurations on the global seismic performance of the structure. Number three is to determine the optimal damper configuration based on structural parameters. And number four is to provide recommendations to improve damper design methods, highlighting insights on genetic algorithms and automated code integration. The study develops an automated design workflow, removing subjective trial and error in damper placement and enabling a systematic retrofit approach. The framework is scalable and modular and applicable to both retrofit and new design. This has potential integration into commercial structural analysis platforms as a decision support tool. Lastly, the study contributes to earthquake resilience by enabling optimized damper placement that reduces structural demand, helping minimize economic losses and improve seismic safety. The study is applied to an existing 9-story reinforced concrete building consisting of a 2-tower configuration connected through a shared podium. This results in a vertically and plan-wise irregular structure layout due to its asymmetric geometry and an even distribution of lateral resisting elements. The study uses fluid viscous dampers modeled as nonlinear velocity-dependent link elements with the following specifications. A reference relative velocity between connecting nodes of 0.4 meters per second is used to characterize structure response during ground shaking, while a maximum force cap of 2,000 kilonewtons is imposed to represent physical and practical damper limits. This study is limited to the superstructure and focuses on the schematic, specifically the parametric design stage of seismic retrofitting. A single set of damper properties is used to isolate the effect of damper placement on structural response without introducing additional variability from differing device characteristics. Damper placement is restricted to predefined locations controlled by architectural considerations. This study does not include detailed member-level retrofit design, local effects induced by damper installation, detailed cost estimation, or constructability considerations. The next slides present the relevant concepts and background necessary to contextualize this study. Fluid viscous dampers, or FVDs, are devices that dissipate seismic energy to control a structure's response to vibration from earthquake, wind, or machinery. They consist of a piston moving within a cylinder filled with viscous fluid, where structural motion causes the piston to move through the fluid, generating a damping force proportional to its velocity. When installed, these devices do not significantly alter the structure's mass and stiffness. To understand how the problem is solved, it is necessary to define how candidate solutions are represented. Each solution corresponds to a specific damper configuration, defined by both the number of dampers and their locations within the structure. This configuration is encoded using a binary string, where each bit represents a feasible damper location, indexed according to its corresponding structural bay. A value of 1 indicates that a damper is installed at that location, while a value of 0 indicates that no damper is assigned to that position in the given solution. A genetic algorithm is a meta-heuristic optimization method inspired by the principles of natural selection and biological evolution. A GA maintains a population of candidate solutions, each representing a possible answer to the problem, with the goal of evolving better solutions over time through iterative improvement. Each candidate, often called an individual, is encoded in a structured form, in this case a binary string. These individuals are evaluated using a fitness function, which quantifies how well each solution satisfies the objective. The algorithm then evolves the population over successive generations using 3 main operators. First is selection, where better performing solutions are chosen as parents, reflecting the idea of survival of the fittest. Second is crossover, where parent solutions are combined to produce an offspring, allowing good traits from the 2 solutions to be inherited. And lastly, mutation, where small random changes are introduced to maintain diversity and explore new regions of the solution space. Reinsertion then determines which individuals from the combined parent and offspring population are retained to form the next generation. Over time, this iterative process drives the population toward higher quality solutions. Fast nonlinear analysis is a time history-based method that uses ground motion records as seismic input. It models the global structure as primarily linear elastic and restricts nonlinear behavior to localized link elements such as dampers. This approach captures the nonlinear force-velocity response of dampers while maintaining computational efficiency comparable to linear elastic analysis, making it highly suitable for iterative optimization frameworks. The general workflow of the study is presented as follows. The process begins with the definition of design constraints and analysis parameters. An initial population of candidate solutions is then generated and subjected to seismic loading using ground motion inputs, after which the structural responses are extracted and evaluated through a defined fitness function. The population is subsequently evolved through standard genetic algorithm operators. This iterative process continues until a specified termination criteria is satisfied. Finally, the optimal damper configuration is identified from the set of evaluated solutions and subjected to engineering judgment for verification and interpretation. The analysis used 11 pairs of scaled ground motion records as seismic input. Each candidate solution is evaluated using 4 performance metrics: damper quantity, interstory drift, story shear forces, and story accelerations. The genetic algorithm uses binary coding with a population size of 50 and a maximum of 200 generations. Selection is performed via tournament selection, with uniform crossover at 70% and random bit flip mutation at 5%. Elitism is set at 20%, preserving the best solutions into the next generation, while a random immigrant strategy of 10% introduces new random individuals to each generation to avoid premature convergence. The fitness function provides a quantitative measure of how well a candidate solution satisfies the design objective based on a defined set of structural performance metrics. Directional and story-based weighting factors are incorporated as heuristic guides to direct the search towards structurally meaningful damper configurations and to define response reductions that have greater structural significance. In addition, a hard constraint is enforced such that any solution is assigned a fitness value of 0 if the mean interstory drift across all ground motion records exceeds 0.03, or if the maximum interstory drift in any record exceeds 0.045. GA metrics are monitored to evaluate the efficiency of the algorithm and the effectiveness of its parameters, specifically the population fitness, Hamming distance, and entropy. Hamming distance measures the average dissimilarity between individuals in the population, while entropy quantifies the degree of randomness or diversity in the genetic distribution. These parameters give insight into the convergence behavior of the algorithm. Here, we see the fully automated optimization process, where each damper configuration is generated and passed directly to the structural analysis software for evaluation. The model is automatically analyzed under the ground motion records. Responses are extracted, and performance is computed through the fitness function. The genetic algorithm then evolves the population, repeating this loop until a termination criteria is reached. The first 7 generations showed rapid and continuous improvement, with fitness increasing sharply from 30.35 to 60.41, indicating strong early-stage exploration where the algorithm quickly identifies significantly better configurations. After this phase, improvements became intermittent, suggesting continued exploration with slower convergence, primarily driven by mutation and random immigrant mechanisms. Early solutions contained up to 41 dampers distributed across both directions, with a concentration in upper stories indicating high initial uncertainty in optimal placement. Over successive generations, the GA progressively eliminated X-direction dampers, reducing the configuration to 16 dampers entirely in the Y direction, and eventually converging to the final optimal solution of 10 Y-direction dampers. The final optimal configuration was identified at generation 145. Seven dampers are concentrated in upper stories where drift and acceleration demands are highest, with the remaining dampers placed at the 5th and 6th floors, all in the Y direction. This confirms that the X direction did not require additional damping consistent with baseline response levels. This configuration produced significant reductions in seismic response. In the Y direction, the peak interstory drift ratio was reduced from an initially excessive value of 0.0358 to 0.0299. In contrast, X direction responses remained close to the baseline with only minor reductions, consistent with the absence of dampers in that direction. Similar trends were observed in story shears and floor accelerations, with clear improvements in the Y direction and near overlapping responses in the X direction, although small reductions were still observed due to torsional coupling. Even in the podium levels where no dampers were installed, reductions in drift, shear, and accelerations were still observed from the ground to the 5th floor. This indicates that modifying the dynamic behavior of the upper critical stories can produce beneficial system-wide effects through global response redistribution. Overall, the optimal configuration provides targeted damping in the direction and locations of highest demand, while also improving overall structural performance through coupled dynamic effects. The following graphs summarize the behavior of the genetic algorithm through several convergence indicators. In terms of fitness, the maximum fitness increases rapidly at the beginning and then enters periods of plateau, which suggests that the algorithm intermittently explores regions where significant improvements are harder to achieve. The average fitness shows a similar trend, strong early gains followed by fluctuations as diverse solutions coexist. Finally, both Hamming distance and entropy decrease over time, showing a gradual reduction in population diversity. Although diversity is higher at the start, it steadily converges as the algorithm progresses, but without collapsing too early. This indicates a balanced search process where exploration is maintained long enough to avoid premature convergence, while still allowing stable convergence toward high-performing solutions. The following points are additional insights derived from the results. First, as the optimization progresses, the evolving solutions increasingly reflect the influence of the initial population called founders, which shape the early search direction and affect both diversity and convergence behavior in the solution space. Second, a properly balanced mutation rate is critical in genetic algorithms, as excessively high values disrupt high-quality solutions, while overly low values may lead to premature convergence and entrapment in local optima. To mitigate this, maintaining population diversity through the introduction of new individuals each generation supports a balanced exploration and exploitation trade-off. Genetic algorithms are capable of identifying efficient solutions that may not be intuitively apparent. Through stochastic operators such as mutation and crossover, they explore complex multimodal search spaces and uncover high-performing configurations that conventional and deterministic methods may fail to detect. Based on the results and analysis presented, several key conclusions can be drawn. One, the irregularity introduces complex interactions between structural components, making the response highly sensitive to damper placement. This results in a solution landscape with many competing local optima, increasing the difficulty of identifying a globally optimal configuration. Second, the first few dampers target the most critical response regions, leading to substantial reductions in seismic demand. As more dampers are added, their incremental contribution decreases. Third, structural response is highly sensitive to where dampers are installed, as certain locations have a greater influence on global behavior. As a result, a smaller number of strategically placed dampers can outperform a larger number of poorly distributed ones. Fourth, dampers placed in upper levels effectively engage dominant vibration modes, which influence the response of the entire structure, leading to reductions in drift and demand in the lower stories as well. For the genetic algorithms, number one, genetic algorithms are well suited for navigating complex solution spaces because they perform global search using a population of solutions. This allows them to explore multiple regions simultaneously and avoid being trapped in a local optima. Second, by incorporating directional and story-based weighting, the search is steered towards regions with higher structural demand. This improves convergence efficiently without restricting the solution space. Third, the optimization framework is modular, allowing changes in parameters, constraints, performance metrics, or objectives. This makes it applicable to a wide range of retrofit scenarios. Fourth, automation allows the algorithm to systematically test a large number of configurations that would be impractical to evaluate manually. Despite the large search space, the framework reliably converged to effective solutions. Lastly, by integrating the optimization algorithm with the analysis software through an API, the entire process is executed programmatically. This significantly reduces computation time and enables large-scale parametric exploration. The following outlines are recommendations that extend this work toward more robust and practical implementations. For damper design, number one, irregularities should be explicitly accounted for, as they significantly influence response behavior and increase the complexity of optimal damper placement. Number two, design strategies should focus on optimizing the placement of the first few dampers, as they deliver the most substantial improvements in seismic performance. Number three, damper placement should be concentrated in floors and directions with the highest demand to maximize global response reduction. Fourth is to use higher fidelity methods such as nonlinear time history analysis to better capture the complex dynamic behavior and validate optimization results. In the case of GA implementation, several recommendations are also outlined. Number one, incorporating structural insights into the optimization process can guide the search toward more effective and physically meaningful solutions. Number two, optimization algorithms should maintain diversity and exploration to avoid premature convergence and ensure robust identification of near optimal solutions. Third, incorporating additional performance metrics can provide a more comprehensive evaluation of structural behavior under seismic loading. Fourth, extending the framework to a multi-objective formulation enables explicit evaluation of trade-offs between competing design criteria. And lastly, dynamically adjusting genetic algorithm parameters during the optimization process can improve convergence efficiency and solution quality. The following lists the references used in the study. And that ends my presentation.
Thank you very much, Engineer Nathaniel. So we now proceed on the question and answer portion of this colloquium for this specific presentation. First, we have here a question regarding your methodology. So the question is, why is genetic algorithm necessary for this specific problem? And why are the other optimization methods are not suitable?
Okay. The problem at hand is basically to optimize the damper configuration in a structure. This is basically a discrete problem since it is a binary decision. Either for a bay, you either have a damper in that location or you do not. So for, let's say, a structure with about 200 feasible locations, feasible damper locations, choosing a subset of, let's say, 10 dampers presents a very large number of possible solutions. This problem is essentially nonlinear since the effect of the damper and the structure are coupled. Second, the solution space is convex and it contains a multiple local optima. And third, the problem is essentially a black box since the objective function is evaluated using structural analysis and not using an explicitly or an explicit expression. So the genetic algorithms are good for these types of problems since they utilize a population of solutions, not only a single solution. So they are good at exploring multiple regions of the solution space without being trapped at a local optima or converging prematurely. Other methods such as gradient descent rely on a function that is differentiable. This problem is essentially non-differentiable, so the use of genetic algorithms is justified for this type of problem.
Okay, thank you for responding to that question. Maybe before we go to the next one, last question for Mr. Nathaniel, is there from the Q&A chat box here in the Zoom, is there a way on how we can tell that the results of the GA optimization are reliable and accurate?
That belongs to the last part of the framework, which is the engineering judgment. So we can just hindi naman pwedeng tanggapin lang natin yung result ng framework. So after the optimization process, we will have a set of solutions or set of configurations that we can manually verify for their practicability and applicability.
All right, thank you. We have another question, but I'll let you to answer this question asynchronously. Later on, you can just type your answer, Engineer Nathaniel. But again, thank you very much for answering the question and for sharing your research. So, maraming salamat. Maybe you can stop sharing and we'll just proceed with the awarding of certificate. So again, This certificate of appreciation is presented to Engineer 𝗚𝗃𝗂𝗂 for sharing his research expertise as presenter in the 2026 Graduate Research Colloquium, given this 24th of April 2026 at the Institute of Civil Engineering, University of the Philippines, Diliman, signed by our director, Dr. 𝗂𝗃𝗂𝗂𝗂𝗂𝗂𝗃. Again, maraming salamat. Thank you very much, Engineer Nathaniel.
Thank you very much po.
All right. At this point, we'll now circle back to the previous presenter. And may I ask Doc Kinay to share the recorded presentation of our speaker, Engineer Hebra. Let's watch this presentation.
Good afternoon, everyone. I am 𝗚𝗃𝗲𝗂𝗂𝘀, and I'm going to present to you my study titled Evaluation of Maintenance Intervention for Rigid Pavements in the Philippine National Road Network. This outlines my presentation. Highways play a crucial role in enabling the safe and efficient mobility. It directly supports the country's economic activities, so proper budgeting and maintenance are critical to keep them reliable and sustainable. To support these decisions, the PWH uses a pavement management system to assess conditions and prioritize maintenance. Despite having a PMS, studies like Dr. Napalang highlight issues in maintenance, including budget misalignment and poor data quality. This leads to inconsistent timing. Some roads are over-repaired while others are neglected, causing disruptions and economic losses. Hence, this study seeks to assess maintenance interventions for rigid pavements to support relevant authorities in enhancing the pavement management system along the Philippine National Road Network by determining the maintenance patterns for primary rigid pavements and identifying the effective timing of interventions using a pavement performance prediction model. These outcomes support key SDGs, SDG 9 through better managed infrastructure, SDG 11 by improving mobility and road safety, and SDG 12 through more efficient use of public resources, ultimately leading to safe and more reliable roads for the public. This study focuses on primary roads and rigid pavements using a calibrated international model to estimate deterioration and service life in Philippine conditions. Other road and pavement types are excluded for consistency, and results depend on the quality of DPWH data. The Philippine National Road Network spans 35,526 kilometers, including 7,463 kilometers of primary road, and with about 62% in concrete. Currently, only 35% are in good condition, highlighting the need for effective monitoring and maintenance. In the Philippines, DPWH uses HDM4 with the RBIA database for its pavement management system. However, outdated models, manual condition assessments, and data limitations make management challenging, highlighting the need for updated, locally calibrated pavement models. Understanding how pavement conditions change over time provides foundation for evaluating its service life and identifying suitable maintenance intervention. In this graph, the x-axis represents the pavement life, while the y-axis is the pavement condition, which is visual condition index. There are actually different pavement condition metrics. The country uses IRI as a standard measure of pavement smoothness, but used mainly for project acceptance, while network-level pavement evaluation relies on the Visual Condition Index, or VCI. VCI is the metric used by DPWH for pavement condition. It is computed by identifying pavement defects, assigning each a weight factor, and combining this into a single score from 0 to 100. Going back to this graph, design life is the time span a pavement design must cover. And in the Philippines, PCCP is designed for 20 years. Pavement starts in a good condition but gradually deteriorate, so DPWH personnel regularly inspect roads and perform routine maintenance to keep them functional. Eventually, pavement deteriorates beyond routine maintenance. Before failure, DPWH applies maintenance to restore condition and extend its service life. Project prioritization is determined using the HDM4 tool, which relies on road condition data gathered through DPWH visual condition assessment. Service life is the time from construction to major rehabilitation, and if not monitored properly, it can lead to early deterioration and higher costs. This table shows when to apply preventive maintenance. According to DPWH guidelines, it is recommended when VCI is between 40.1 and 70. Pavement service life is influenced by several factors such as environment, traffic, thickness. Flooding and moisture all accelerate deterioration. Heavy traffic accelerates cracking, and thicker layers improve structural response and fatigue resistance. While many factors exist, this study focuses on traffic loading and pavement thicknesses, as these mostly strongly affect deterioration. Pavement prediction models help forecast deterioration and guide maintenance. They include deterministic models, which are simple but limited, probabilistic models, which capture uncertainty but need quality data, and machine learning models, which are accurate but data-intensive. Each type has strengths and limitations, and the appropriate model depends on availability of data and accuracy needed. In countries with limited pavement data, deterministic models are often the most practical. In the Philippines, our pavement data in DPWH only goes back to 2007 and has quality issues, making deterministic models the most feasible option. Among this, the sigmoidal model captures S-shaped deterioration and improves reliability by reducing rating errors and bias through time shifting. International studies strongly support the sigmoidal model. Studies by Wu, Beckley, Kaya, Medina, and El-Hadidi report high accuracy with R-squared values up to about 0.99 and realistic pavement deterioration predictions across different models and datasets. Overall, sigmoidal models consistently capture pavement deterioration even with limited data, making them well-suited for the Philippine PMS context. To achieve the objective of the study, this methodological framework was followed. Data for the study were obtained from the DPWH planning service, including construction history, rehabilitation timelines, VCI, and CECL, with records available from 2007 to 2023. Road sections were grouped into families based on similar deterioration using traffic loading and slab thickness, classified as light, moderate, or heavy. Data were cleaned for consistency, and although records covered 2007 to 2023, only 2011 to 2023 were used because earlier data showed inconsistencies in section IDs and stationing. Sections with asphalt surfaces, unclear ages, or uncommon thicknesses were excluded, and the final map shows the sections included in the analysis. Pavement performance was modeled using the sigmoidal approach following Elkawaga and Wu. After grouping the sections, VCI trends were reviewed to identify when a pavement underwent maintenance intervention. A reset occurred when the surface changed to asphalt. Average intervention age was then recorded for each family. Each road section was plotted using VCI versus age. When VCI increased from 1 year to the next due to routine maintenance, the section was split into new segments starting at age 0. Segments with continuous VCI increases were removed, as they likely reflected subjective ratings rather than real pavement behavior. All segmented data were entered into a spreadsheet. Each segment was assigned a time shift value, and the reduced years were computed to properly align the segments on the sigmoidal curve. This study uses Wu's sigmoidal model, where VCI is related to reduced time through parameters A, B, C, and D. This describes the deterioration curve with initial values assumed before optimization. Using the assumed parameters, we computed the predicted VCI for each segment and calculated the squared error between measured and predicted values to assess model accuracy. We use Excel solver to adjust the sigmoidal parameters and time shift values, minimizing the squared errors to find the best fit. Time shift limits and constraints ensured VCI stayed between 0 and 100, and that the curve started near 100 at age 0. We optimized the model by increasing the time shift in 5-year steps until R-squared changes were below 0.005, improving alignment and achieving the best fit. So the optimized sigmoidal model was then used to predict when each pavement family would reach the VCI threshold. So these curves were generated based on the calibrated sigmoidal model, representing how pavement condition typically changes over time. What is immediately noticeable is that instead of showing a long stable period after construction, all families exhibit a steep early drop in VCI. This confirms what earlier studies observed, that early deterioration is common in Philippine pavements due to factors such as material handling, base preparation, and curing quality. For 230 mm pavements, deterioration depends on traffic. Under light traffic, VCI 70 occurs at 3.7 years and VCI 40 at 9.5 years, aligning with the 8.4-year intervention age, with these sections staying in good condition longer. For moderate traffic, deterioration is much faster, with the VCI 70 to 40 range occurring between 2.5 and 6.5 years. The average intervention age of 9.87 years exceeds this range, suggesting structural limitations of the 230 mm slab under higher loads. For heavy traffic, deterioration is more gradual, with a VCI 70 to 40 interval of 3.3 to 8.5 years, closely matching the intervention age of 8.57 years. For 280 mm pavements, deterioration is generally slower, showing the benefit of increased thickness. Under light traffic, pavements reach VCI 70 at about 8.4 years and VCI 40 at 21.5 years, indicating a long preventive maintenance window. However, the average intervention age of 6.29 years is too early, occurring before maximum benefit is achieved. For moderate traffic, deterioration is still the fastest among the group, but more gradual than 230 mm pavements. The preventive window is 3.6 to 9.4 years, with interventions 9.44 years, typically occurring near the upper limit. For heavy traffic, deterioration is stable, with a 5.0 to 12.8 year window, and intervention timing at 8.6 years aligns well with recommendations. The results show that traffic loading alone does not determine pavement performance. Structural capacity and construction quality also play key roles. Comparing predicted intervention windows with actual practices reveals inconsistencies. In some cases, maintenance is done too early, such as in the 280 mm light traffic pavements, where interventions occur before reaching the optimal VCI 70 to 40 range. In contrast, 230 mm moderate traffic pavements deteriorate faster, yet interventions are slightly delayed, possibly due to construction issues or overloading. Some sections, however, align well with the VCI 70 to 40 range, indicating more appropriate timing. These findings indicate that maintenance decisions are not always guided by pavement condition or performance trends alone, but may also be influenced by programming constraints, standard project bundling practices, or institutional policies. Aligning them with performance-based thresholds can improve timing, efficiency, and long-term performance. Model accuracy was evaluated by comparing measured VCI from DPWH with predicted values, showing strong agreement with R-squared values of about 0.798 to 0.892. Some overprediction occurs at lower VCI levels, but overall bias is minimal. Models with more data points perform better, highlighting the importance of continued data collection for improving reliability. Model validation using independent data showed reasonable predictive performance. For 230 mm pavements, R-squared values range from 0.687 to 0.786, while 280 mm pavements showed 0.72 to 2.843, with the strongest results under heavy traffic. Overall, despite lower values than calibration, the model remains reliable, though performance is influenced by sample size. In conclusion, maintenance interventions are not consistently condition-based, with rigid pavements typically receiving maintenance between approximately 6.29 to 9.87 years, earliest in light traffic sections and latest in moderate traffic sections. These variations are not solely traffic-related and may be attributed to differences in construction quality, materials, drainage conditions, VCI measurement consistency, and maintenance decisions driven by programming rather than actual pavement condition. The calibrated models revealed early pavement deterioration with little to no flat in the portion in the expected S-curve, indicates a need for stronger construction quality control and stricter compliance with specifications to prevent premature pavement failure. Light traffic 280 mm pavements were treated earlier than recommended, while moderate traffic 230 mm pavements deteriorated the fastest, possibly due to overloading, and were treated later than ideal. However, several pavement families aligned well with the predicted intervention window. Using the calibrated sigmoidal models, the study identified effective timing of intervention, distinguishing fast from slow deteriorating pavements and enabling properly timed condition-based maintenance. For further study, it is recommended to extend and validate pavement prediction models for secondary, tertiary, and local roads across the Philippine network, include subgrade and environmental construction quality, and economic factors to enhance model accuracy and support cost-effective planning, and expand model calibration to flexible and composite pavements to enable broader performance forecasting and enhance the DPWH pavement management database. And that would be all for my presentation. Thank you so much.
Thank you very much, Engineer Hebra, for your presentation. So we'll now proceed with the Q&A for this colloquium. We just have one question here. Based on your presentation, because you presented in your paper or in your research different predictions based on your model. The question is, when should maintenance interventions be carried out to maximize pavement performance based on prediction models? And perhaps a follow-up question to that, are there any specific maintenance interventions that are recommended based on the prediction model?
Actually in this study we only considered the asphalt overlay since that is the data that is can be acquired from the DPWH. Maintenance intervention should be applied as within the VCI 70 to 40 range identified by the calibrated SIG models which varies by pavement type and traffic. So aligning interventions with this window allows for timely condition-based maintenance, so improving pavement performance and avoiding premature or delayed repairs.
Okay. So thank you very much for answering the question. Again, maraming salamat. We'll now proceed with the awarding of Certificate of Appreciation to Engineer 𝗚𝗃𝗂𝗂 for sharing your research expertise as presenter in the 2026 Graduate Research Colloquium, given this 24th of April 2026 at the Institute of Civil Engineering, UP Diliman, signed by our director, Dr. Jose Regine Regidor. Again, thank you very much, Engineer 𝗚𝗃𝗂𝗂, for sharing your research to our audience for today's colloquium.
Thank you so much, Doc.
Okay, so for our next and I think last presenter for this colloquium, let me just introduce to you our next speaker. He is Engineer Drexler B. Sibal. He is a licensed civil engineer. He earned his Bachelor of Science in Civil Engineering from Cavite State University in 2012 and recently completed his Master of Science in Civil Engineering, major in Transportation Engineering at the University of the Philippines, Diliman. He served as the program coordinator for BS Civil Engineering from 2018 to 2024 and is currently the internship supervisor of the College of Engineering and Architecture in his institution. Before joining the academy, he worked as an inspector at the Minerals Division of SGS Philippines and as a science research specialist at the DOST Metals Industry Research and Development Center, or MIRDC, under the Advanced Transportation Group. Again, let us welcome our next presenter, Engineer Drexler Sibal.
So good afternoon, everyone. So let me share my presentation first. Okay. Okay, so let me just check if kung yung nag-share po na screen ko is the full screen of my presentation.
Yes, but we're seeing the slide about background of the study. Can you go to your title slide first, I think?
Okay. Okay, so
Okay.
Okay, so good afternoon, everyone. I'm Director Sibal, and today I will be presenting my research entitled Assessing the Impacts of Various Fleet Replacement Strategies on Air Quality and Health using 𝗏𝗏 Dispersion Model, the case of 𝗏𝗏 City So my advisor was Dr. 𝗏𝗏𝗀𝗃. And simply put, this study asked if we modernize our transport system, how much can we actually improve air quality and public health? So, okay, so to begin with, air pollution remains a major concern in the Philippines, and in fact, mobile sources account for a significant portion of total emissions. And because of this, improving the transport sector becomes a key strategy in addressing air quality issues. Okay, so, and because of this, the Philippine government introduced the Public Transport Modernization Program, or the PTMP, formerly and still commonly referred as the Public Utility Vehicle Modernization Program, or the PUVMP, which was the project of the Department of Transportation in 2017, which aims to replace the old vehicles with cleaner ones. So the program aligns with Lee Schipper's ASIF frameworks by reducing emissions through improved activity efficiency, enhanced mode share, lower energy intensity, and cleaner fuel technologies. But here's the key question. Will this be enough to significantly improve air quality? And that's what this study tried to answer. So the goal of this study is simple: to evaluate how different transport modernization strategies affect air quality and health, and more importantly, to identify which strategies actually make a meaningful difference. And okay, so the study focuses on a busy intersection in 𝗏𝗏 City. And why here? Because it reflects a typical urban area with increasing traffic. And one important finding early on is this: motorcycles and tricycles actually dominate the roads, not jeepneys. And this becomes very important understanding the results later. So to answer the research question, I use a simulation approach. I use 𝗏𝗏 dispersion model to simulate pollutant concentrations, and AirQ+ was then used to estimate the health impacts. In simple terms, I created different what-if scenarios, such as what if we replace jeepneys with modern ones, and what if we use electric vehicles, and what if we electrify both jeepneys and tricycles. Then I use a model to estimate how pollution spreads in each scenario. So to make the model realistic, I collected traffic data, what vehicles are on the road measurements, and weather data, and these factors affect how pollution behaves in real life. So before going to the results, there is one important observation. Jeepneys are only about 13% of the traffic, and most vehicles are motorcycles and cars, private cars. So even before the results, we are already expect that focusing only on jeepneys might not be enough. And after preparing the inputs in estimating vehicular emission rates, spreadsheets were prepared to calculate emission rates in 𝗏𝗏, which considers total vehicle count, emission factors, road width, and emission factors were sourced from JICA roadmap for transport infrastructure development for Metro Manila and surrounding areas. And the vehicle fuel assumptions from the same report were also adapted to ensure consistency in the analysis. In essence, the model estimates how pollutants disperse from traffic under different scenarios that presented earlier. And to evaluate the results, pollutant concentrations were compared against WHO and DNR guidelines. Additionally, pollutant levels were converted into AQI values using the US EPA's 𝗚𝗏 AQI calculator. As we can see, higher AQI values indicate greater pollution and health concerns, and as presented by AQI colors. And now the results. Starting with the carbon monoxide, all scenarios here are within acceptable limits. All scenarios from the business as usual scenarios fall within moderate AQI category, suggesting minimal health risk, but electrification scenarios involving the full electrification of tricycles and jeepneys showed further reductions. So this indicates that carbon monoxide is already controlled, but can still benefit from cleaner technologies. And these contour maps compare the business as usual scenario with the electrification scenarios, which demonstrated the most significant reductions in the carbon monoxide concentration based on the simulation results. And this contour map reveals a noticeable reduction with CO concentration decreasing from the 𝗏 scenario to electrification of tricycle and jeepney scenarios. And for the next pollutant, which is NO2, or the nitrogen dioxide. So in contrast, NO2 results showed a different trend. So although there were reductions, also all scenarios remained in the unhealthy category. So this limited improvement is likely due to the distribution of vehicle types in traffic flow, since NO2 emits by both diesel and gasoline, mainly by cars and motorcycles. So this contour maps simulated from the 𝗏𝗏𝗱𝗏, that these maps indicate a visible decrease in NO2 concentration from the business as usual scenario to electrification scenarios. And still, these results show that all scenarios remain in red or unhealthy category, and this suggests that sources beyond jeepneys, particularly the private cars and motorcycles, continue to dominate NO2 emissions. And for SO2, all scenarios met guideline values. All scenarios fall within the good AQI category, probably because of the absence of industrial SO2 sources in the model, since the simulation focused exclusively on emissions from the roads only, excluding potential contributions from other sources within the area. And significant reductions were observed, especially in the electrification scenarios. And these contour maps this contour map shows a clear decrease in SO2 levels is observed from the business as usual scenario to the electrification scenarios, with further improvements seen in the combined electrification of tricycles and jeepney. And this confirms that diesel-powered vehicles are major contributors to SO2 emissions. For PM2.5, all scenarios remain in the unhealthy category, even with full electrification. Concentrations were reduced by about 46%, but still exceeded the guideline values. But the results show significant reductions in pollutant concentration across scenarios. So this confirms that electrification contributes to a decrease in PM2.5 concentrations, but these results highlight that while electric vehicle replacements reduce PM2.5 levels, they remain above the WHO and DNR guidelines due to the contribution of other vehicles like motorcycles and private cars in the area. So, as shown in this map, these contour maps of PM2.5 concentration focusing on the intersection with the highest traffic activity, and the maps compare the business as usual scenario with the complete electrification of tricycles and jeepneys, and where the most substantial reductions in PM2.5 levels were observed in this simulation results. So the map reveals a noticeable decrease in PM2.5 concentration in the complete replacement with electric tricycles and jeepney. So at this point, one important question arises: why are improvements still limited despite modernization? So the answer lies in the traffic composition. Private vehicles and cars, major contributors, were not fully addressed in the main scenario. So even before the results, we already expect that focusing only on the jeepneys might not be enough. So to explore the electrification of private vehicles further, a sensitivity analysis was conducted by simulating additional scenarios that assumed stepwise electrification of private cars. As electrification increases from 20% to 50%, air pollution consistently decreases. At 50%, PM2.5 drops enough to reach moderate air quality with about a 70% reduction from the current condition. So in summary, when private vehicle electrification was included, PM2.5 reductions reached up to 70% and AQI levels improved significantly. And this highlights that a system-wide approach is necessary. So a broader strategy that includes private vehicles is necessary to achieve significant air quality improvement. Now, to translate these findings into real-world impact, health assessment was conducted using AirQ+. The health impact of its scenarios was evaluated focusing on 3 key metrics: the attributable proportion of cases, estimated number of attributable cases, and cases per 100,000 population. And the results demonstrate that the baseline scenario has the highest health burden comparing to the modernization scenario, and results in modest reductions, but the most significant improvements are seen in the full electrification scenarios. So full electrification of both tricycles and jeepneys achieves the lowest values, that is 1.30% attributable proportion, 5 estimated cases, and 5 cases per 100,000 population, highlighting the substantial health benefits of a fully electric fleet. So this result shows that electrification reduces the number of pollution-related cases, and full electrification resulted in the lowest health risk, cutting cases by almost half. So, in conclusion, this study assessed how replacing public transport vehicles with cleaner electric alternatives affects air quality and health in Trans-Martira City. So results shows that electrifying jeepneys and tricycles significantly reduces air pollutants. So we also found that including private vehicles in electrification leads to even greater improvements with up to 70% reduction in PM2.5 and better air quality levels. So health results confirm fewer pollution-related cases under cleaner transport scenarios as simulated in AirQ+. Overall, the study shows that transport electrification, especially when expanded to private vehicles, can greatly improve air quality and public health. So, for recommendation, future work should expand the study to more intersections, improve model accuracy through calibration, and include other vehicle types and pollution sources. It is also recommended to assess long-term health impacts and conduct cost-benefit analysis. Overall, this will help improve future transport planning and air quality management. If other cities or municipalities aim to assess the impact of various fleet replacement strategies on air quality, they can adapt the methodologies used in this study. The approach integrates air dispersion modeling using AirMod, health impact assessment via AirQ+, and secondary data such as traffic volumes and emission factors. With calibration to fit local conditions, this framework can serve as a guide for evaluating the effects of public transport modernization programs and similar interventions. And with that, I conclude my presentation. Thank you very much.
Thank you very much, Engineer 𝗖𝗵𝗂, for sharing your presentation that is, I would say, very relevant in the context of Philippines, considering that we have many challenges in the transportation sector right now and in the ongoing energy crisis. We just have a question here for you, Engineer 𝗖𝗵𝗂. based on the result of your study, it shows that even with public transport modernization, PM2.5 levels remain unhealthy. So, what additional strategies does your research suggest to basically achieve acceptable air quality levels?
So, while public transport modernization already provides significant reduction, it is still not enough to bring PM2.5 to acceptable levels. So the reason is that aside from jeepneys and tricycles, private vehicles, especially cars, continue to contribute a large share of emissions. So because of this study, the study suggests that a more comprehensive approach is needed. In particular, this includes a partial to a large-scale electrification of private vehicles, as well as policies that reduce reliance on high-emitting transport modes. In fact, the sensitivity analysis showed that once private vehicles were included in the electrification strategy, the reductions in PM2.5 become much larger and improve AQI levels, highlighting that broader interventions are necessary. Thank you.
Okay, very well said. Maraming salamat, Engineer Sibal, and
Thank
again,
you po.
congratulations. We'll now proceed with the awarding of Certificate of Appreciation. Let me just share the screen. Again, this Certificate of Appreciation is presented to Engineer Drexler Sibal for sharing his research expertise as presenter in the 2026 Graduate Research Colloquium, given this 24th day of April 2026 at the Institute of Civil Engineering, University of the Philippines, Diliman, signed by our director, Dr. Jose Regine F. Regidor. Again, congratulations, and thank you very much, Engineer Sibal. Okay, can we just request our presenters and our hosts to open your cam for a quick photo opportunity? So, yan. Pwede na siguro mag-smile yung mga presenter natin kasi tapos na mag-present. So, si Engineer Ropero, can you open your cam? Sige, perhaps baka may connectivity issue din si Ma'am Christine. So, let me just take a photo for this group in 3, 2, 1. Smile. Okay, 1, 2, 3. In 3, 2, 1. Smile. Okay, maraming salamat po for joining this presentation. At this point, I think we have reached the point wherein we need to synthesize or conclude this program. So may I turn this over to Dr. Errol Kinay for some closing message, some instructions. Back to you, Doc Kinay.
Okay. Thank you, Doc Hill. Yeah, we have completed all the 5 presentations for this part 2 of the graduate research colloquium. We heard a lot of very interesting completed theses, and well, I would like to thank our presenters, Engineer Rapero Alonte, Engineer De Vera, Engineer Hebra, Engineer Pasiliao, and Engineer Sibal for sharing your completed thesis to our audiences, to the public, for giving time for this graduate research colloquium. I would also like to thank my co-moderator, Dr. Hill Cruz, Assistant Professor Diola, our student assistant, Jilan Evangelista, our Institute Director, Dr. Jose Regine Regidor, Deputy Director 𝗘𝘃𝗲𝗂𝘀𝗲, our program advisors, the ILC of Diliman for supporting this Zoom meeting. And I would also like to thank the participants now for attending our graduate research colloquium. I hope you learned a lot from the presentations. So at this point, I would like to share now the feedback form. So the feedback form, you can scan by QR code. I'll also give the link in our chat box. So if you want to give feedback, you have other questions that you need to relay to our presenters. If you want to receive certificates of attendance, so you may use this link and QR code. So again, thank you very much for attending, and everyone may leave the meeting when after completing the